Bismillah ar-Rahman ar-Rahim. Let's continue our class. Bonding. Okay. A bond is formed when two atoms share, lose, gain, or gain electrons in the outermost energy shell. Look at the periodic table here. The key factor in bonding is the electronic configuration. Electronic configuration. How? Here, energy levels. Electrons are distributed here. The first energy level has maximum 2 electrons. Here, maximum 8. Here, maximum 18, but if it is the last, so only 8. Maximum 32, but if it is the last, maximum 8, and so on. Okay? Anyhow, electrons are distributed like this. Here, hydrogen and only 1 electron, it is present in the first energy shell. Helium in the first has 2 electrons in the first energy shell. So the first energy shell is saturated, and this is called noble gas. It's inert. It's not active. It's satisfied. Lithium has 3 electrons. 2 here, satisfied with 2, and only 1 in the outermost energy shell. Beryllium has 2. This can adapt to 8. Boron has 2 and 3. Carbon 4. Nitrogen 5. Oxygen has 6 in the outermost inner shell. Fluorine has 7 electrons in the outermost inner shell. And so on. Sodium has 1 electron in the outermost shell. Here has 1 in the outermost energy shell, 1 in the outermost energy shell. All of this has only 1 electron in the outermost energy shell. Here, everyone in column 2, everyone has, it's called column or group, has 2 electrons in the outermost energy shell. All these transitional metals, transitional elements has 2 electrons outermost energy shell. They are subdivision of 2. All these has 3 electrons in the outermost energy shell. Has 4, has 5, has 6, has 7. And these are noble gas, saturated at 8, saturated at 8, saturated at 8. The outermost energy shell is saturated at 8. The outermost 8. Only 2 because it is the first energy. They are called noble gases, inert gases. They are happy because they are saturated. They have saturated outermost energy shell. Okay? They are happy. And all other elements in the periodic table are not happy. Why? 1 minute. All other elements in the periodic table are jealous about noble gases. They need to become like them. They struggle to have their outermost energy shell saturated at 8. They are jealous about noble gases. Fluorine has 7 electrons in the outermost energy shell. It's eager to have it 8. Okay, it struggles to have 8. Oxygen needs 2 electrons to become 8. Lithium, it is easier to lose 1 rather than gaining 7. Beryllium, magnesium, easier to lose 2. Atoms having 5, 6, or 7 electrons outermost energy shell, easier to gain. to have to become similar in electronic configuration to the nearest coming noble gas and to have their outermost initial saturated at 8. Elements having 1, 2, or 3 electrons outermost initial, it is easier to lose than gain. To have their outermost initial saturated at 8 and become similar in electronic configuration to the previous noble gas. This comes to the question, why do atoms react? Why? This is a crucial question in chemistry. Why do atoms react? To have their outermost energy shell saturated at 8, except hydrogen, and to become similar in electronic configuration to the nearest noble gas. How do they react? They either lose, gain, or share. Lose, gain, or share. How? Let's know. Look here. Look the periodic table. Sodium. Sodium has sodium 11, 23, right? 11 electrons are distributed like this. 2 electrons the first energy level, 8 electrons second energy level, and here only 1 electron the outermost initial. Mr. Lewis describes it like this. Chlorine, what is chlorine? 17. Chlorine, 17 protons, so 17 electrons. Chlorine, 17, 35.5, and 35, okay. Has 2, 8, and 7 electrons in the outermost energy shell. Mr. Lewis describes it like this. 1, 2, 3, 4, 5, 6, 7 electrons outermost energy shell. We are concerned with the outermost energy shell because that's the cause for chemical reaction. Inner energy levels do not share in or participate in combination in chemical reactions. Mr. Sodium, are you happy? No, I'm not happy. Why? I have only 1 electron outermost initial. I need it to become 8. Is it easier to lose or gain? It is easier to lose. Okay. Chlorine, Mr. Chlorine, Miss Chlorine, are you happy? No, I have only 7 electrons outermost initial. I need to death. I need very much to make them 8 to become similar electronic configuration to the nearest noble gas, which is neon, right? Which is argon, sorry. This is not happy. It has 1 electron. This is not happy because it needs electron. What happens when an atom of sodium meets an atom of chlorine? Oh yeah, they will be very happy to meet together because sodium will find a chance to lose its electron and the chlorine will find its chance to have electron. So it will become like this. Sodium lost electron and now satisfied and very happy because it has only 8 electrons outermost initial and it is like neon. It was jealous to neon, but after losing electron, it will find itself having a positive charge. Okay. Chlorine is very happy because now it has 7 electrons outermost in the shell. It gained an electron, but after gaining an electron, it will find itself having negative charge. So electrostatic attractive force between sodium and chlorine will make them a molecule of sodium chloride. This is called ionic bond. If you are very, very small of their size, you can pass through them because there is not a physical existence of this bond. Although there is no physical existence of this bond, but it's very strong. This is called the ionic bond. An element, usually metal, loses an electron and non-metal gains these electrons, and electrostatic attractive force attracts them, make a molecule. But what if chlorine does not find sodium and still it is unhappy? Okay. My sister chlorine, why aren't you happy? Because I only have 7, I need 8. You need 1 electron? Yes. Me too, I need 1 electron. What about if we share? How? Every atom of them shares an electron here to become sharing. 1 electron from you, 1 electron from me, and we share. Now I feel I have 8 and you feel you have 8. This is called covalent bond. Okay? Every atom shares with an electron. Every 2 electrons make 1 covalent bond. Although it has a physical existence, you cannot pass here, but it is weaker than ionic bond, and you will know later why. Hydrogen, in the same way, binds with hydrogen to make monoatomic, monocovalent bond. Chlorine, monocovalent bond. Oxygen, share 2 dicovalent bond. Nitrogen, share 3 triple covalent bond. Covalent bonds. So now we have ionic bond and covalent bond. In oxygen, electrons are shared in the middle because protons here attract and the protons here attract. They are of equal number and equal strength. Chlorine has 17 protons. Chlorine has 17 protons. So the electron pair, the pair of electrons shared is in the middle. But what if hydrogen shares an electron with chlorine? Hydrogen has only 1 electron, has only 1 proton, and these 17 proton. The electron shared here will be attracted to chlorine. The electrons will be attracted here. So hydrogen side will be slightly positive and chlorine side will be slightly negative because electrons are attracted here. It is a molecule. Yes, it is a molecule with covalent bond. It has a physical existence, but it will become polar like a battery, small battery. Here positive, here negative, but it is a molecule intact, not like sodium chloride. Sodium chloride once mixed with water, this is positive and this negative, this will go here and this will go here and move free. But here, they will move together. Okay, water, H2O. Oxygen has 6 electron outermost initially, it needs 2. Oxygen needs 2 to have to saturate it. It will negotiate with 1 hydrogen and another hydrogen, like this. make a covalent bond with one hydrogen, another hydrogen. But the electrons are attracted to the to the 8 protons. Here only one poor proton, but here 8 protons. So the electrons will be attracted here. So oxygen side will be slightly negative. Water side will be slightly positive. And this is called a polar compound. Polar. This is called polar covalent bond. Polar covalent bonds making polar compounds. Polar compounds. Becomes like this. Example of polar compounds: glucose. Glucose is polar compound. Although it's a molecule, but it dissolves in water because it is polar compound. Carbon dioxide. No, but carbon dioxide is non-polar. I'll tell you why. Look, carbon shares with oxygen here, with oxygen here. Okay? Carbon has 6 protons, here has 8 protons. Electrons are slightly attracted to oxygen. Here will become slightly negative, here will become slightly negative, and the positive inside. So it is non-polar. It is non-polar. When polar, when you find a side positive and another negative, this is called polar, but carbon dioxide is non-polar. Anyhow, glucose is polar. Water is very, very polar. It's very polar compound. It's very polar. So we don't say water polar, we say hydrogen bonds. When hydrogen reacts with oxygen, it makes a very strong polar compound called hydrogen bonds. So water has hydrogen bonds. It is a polar covalent bond with hydrogen, but when hydrogen have polar covalent with oxygen or nitrogen, it's called hydrogen bonds. Hydrogen bond. It will have a great effect in the structure and function of water, right? So we have 3 types of bonding. Ionic bond between metal and non-metal, one lose, one gain, and change into ions. Sodium chloride is an example. Here becomes a positive, here becomes a negative. When dissolved in water, sodium will move alone. Chlorine will move alone. Now it is not an atom, it is an ion. Positive ion called cation. Negative ions called anion. Positive ions are called the cations, negative ions called anions, and sometimes you have polyatomic ion, like you know, H2CO3. This is in water, hydrogen moves alone, and CO3, it is an ion too, cation. Okay, cation. Like SO4, it is a polyatomic ion, a group SO4 has double. PO3, phosphate group, has 3 negative ions. These are also ions, but polyatomic ions. So we have ionic bond. We have covalent bonds here sharing and make a molecular compound. Molecular compound. It's molecule. But ions are ions. Here ions, they separate in water. But this does not separate in water, but it has a positive end and negative end. Here attracts the negative end in water, and I'll explain it later. Polar covalent bond. Polar covalent bond, it comes when there is unequal distribution of charge inside the molecule. Intermolecular attraction. You know the difference between atom and the molecule. atoms. This is molecule. Why is solid a solid? Why is liquid a liquid? Why is gas a gas? Molecules of solids are regularly arranged and fixed in their place. Okay, solid. They have intermolecular forces. Intermolecular means between molecules. High. It has kinetic energy of molecules. How? Kinetic energy, do they move? No, but they hesitate. They vibrate in their places. Molecules vibrate in their places. They are crazy mad. They are not stable. Why? I'll tell you. They have intermolecular forces, strong, kinetic energy of molecules, weak. Okay? Intermolecular spaces are small. When you heat solid, change into liquid. Intermolecular forces are less. You break bonds, intermolecular bonds, intermolecular forces. Kinetic energy of molecules are more, they slide over each other. They move, they vibrate in their place and vibrate and translate, slide over each other to make fluid. Intermolecular spaces are larger. Gases move when you boil a gas, a liquid, it changes into gas. Molecules move very, very, very fast. In space, 500 meters per second. Wow. At room, say 100, 200 meters per second. It's very, very fast. Intermolecular force is nil, zero. Kinetic energy of molecules are very, very, very high. To the extent that they translate, they move 500. Intermolecular space is much. There's difference between solid, liquid, and gas. I describe this to say that there is intermolecular forces. How do molecules bind to each other? Okay. Polar attraction, when two or more atoms form a bond, the entire resulting molecule is either polar or non-polar. Okay. There are strong attraction between polar molecules, like water. Look here. Glucose has a polar end, positive end, and negative end. It attracts to the negative of the neighboring molecule. Unlike this, make crystals, and so on. But it is an intact molecule. Okay? What about water? Water has a polar compound. As we said before, hydrogen is slightly positive, hydrogen is slightly positive, oxygen is slightly negative. But it is very, very polar, very, very polar, because electrons, hydrogen is very weak, and electrons are lost from it, nearly lost, It's very attractive here. So the hydrogen of this molecule, it is an intact molecule, not broken. It needs electricity to break it. Is attracted to the negative of the neighbor molecule. Slightly attracted. It has hydrogen bond, weaker than covalent bond, but still it's bond. So molecule here, molecules are attracted to each other by hydrogen bonds. It's called polar bonds, polar intermolecular attraction. Hydrogen, water is highly polar molecule, like this. Hydrogen bonds, it is not intramolecular, it is intermolecular. Inter means between, molecular. bond. What's meant by inter? In between. What is intramolecular? What's meant by intramolecular? Intramolecular bonds are either ionic, covalent, or polar covalent. You know the difference? Intramolecular, inside the molecule. It is the bonds we studied. But intermolecular, this is a molecule, this is a molecule, this is a molecule, this is a molecule. Here's some intermolecular attractive force binding to them. Hydrogen is one type of intermolecular bonds binding molecules together. Okay, hydrogen were very important in biology, in water, and it is the cause of many peculiar characters of water. It keeps two strands of DNA bound together, causes water molecules to stick together. What about non-polar molecules? Only the weakest attraction called van der Waal attractive force. Van der Waal attractive force, the German man. Non-polar compounds have weak, so they are usually gases. Or have boiling point, small boiling point, either like wax, this number, like oil, like fat. Okay, it's called van der Waal attractive force. Don't think of it. It needs a long time to explain. Carbon dioxide is non-polar. Okay. Water is water. Hydro means water. Water is polar, very polar. Okay. Polar compounds dissolve in water. Polar dissolve in polar. Okay. Especially water. Water is a very polar compound. So all ions, all ionic compounds dissolve. Why? Because ionic compounds have positive end and negative end. They dissolve to the extent that they separate, move freely. Polar compound, example glucose. Glucose has a positive end and negative end. Okay. Look, molecules of water are crowded. Look, glucose. Before, in crystals, glucose is like this. Positive, negative, negative, positive, positive, negative, and so on. Here, when water, small molecules of water come, they are crowded over this. Here, positive glucose. Water will become like this. Oxygen, hydrogen, oxygen, hydrogen, oxygen, hydrogen, like ants. And here, glucose, it becomes like this. Sorry. It becomes like this, sorry. There is a mistake here. Okay. This is glucose. Positive, it will attract the negative pole of water, negative side of water. Here, negative, it will attract the positive side of water, hydrogen. Okay? And the other in the same way. Okay? So molecules of water will take them away from each other. This is called dissolving. Right? So polar dissolve water, polar. All polar compounds and ionic compounds are dissolved in water. Right? It's called dissolve like dissolve like. Or about non-polar, but also non-polar, dissolve non-polar. Example, alcohol. We use alcohol to clean oily stains. When you have an oil stain on your shirt, you clean it with alcohol, with gasoline. right? Oily gasoline, okay? In mechanic workshop, they wash their hands with gasoline, petroleum, alcohol, okay? Lipids are nonpolar. They are called hydrophobic. What's meant by hydrophilic and hydrophobic? Substances dissolve in water called hydrophilic. Feel means love. Love. Phob means hope. Phobia. Hydrophilic, like water, dissolve in water. Hydrophobic, like oil. Hydrophobic does not dissolve in water. When you put oil in water, okay, it separates. Oil above and water below. It's called the hydrophobic. Lipids are hydrophobic. They are non-polar. They do not dissolve in water, dissolve in alcohol. The plasma membrane is a phospholipid bilayer. It's an oily barrier. The cell is here. It has water inside and water outside. The cell membrane is a phospholipid bilayer, non-polar, oily barrier, separates substances outside from inside to keep the integrity of the cell. Okay? Large polar molecules cannot diffuse through plasma membrane. Non-polar, small non-polar can diffuse, and they have some other mechanism. Okay? Next section, we'll have some questions on this. Next class, we'll study characters of water. Thank you.